what we call a regression analysis. A regression analysis is important because it allows us to assess the reliability of our data, how well we were able to repeat the same experiment and get a reliable result. So first of all, I'm going to just show you how to rearrange a little bit of this data. First of all, for all of these ones over here, we want to just label them because we're going to change well, actually what we'll do is we'll just copy and paste our data. So if you take your data here all the way down, all of your different trials, just copy them and paste them down below or across. I'm just going to do below. Now all we need to do is strip out all of the details here so that we can do what we call a regression analysis. It sounds crazy, but it's actually not too hard. So what I want you to do first is, for all of these trials here, if they're day 0, just put the day in that it's about. So this is day 0, and just copy that down. So this is all day 0 data. Put that in there so the day that we are taking the measurement on is beside the measurements that it applies to. Do that first for all your data. So this is day 3, so all of these have to have that day in there because that's what's going on the bottom of our graph, the day, and then on the side of our graph we'll have the counts. So that's the very first thing you got to do in here. Change out all these trials. It doesn't matter which trial it was anymore. We just want to know what day those counts took place on. I'll zoom in a little bit more so you can see what I'm doing. So here's day 7. Okay, so now I've done that. Next thing is you have to delete anything without data in it. So delete all of your empty trials. It can't handle holes. That one there has a hole there too, so we'll have to delete it as well. Okay, next thing. You need to delete all of these mean, modes and medians, so it's just the raw data. Remember, you have them above anyway, so that's okay. So you end up with basically a very, very simple table here of the day and the counts that you took. And that's it. Very simplified data just in those 3 columns like that. And we're going to be going and doing a regression analysis on that data. Okay, so get to that stage and then start the video again. You'll have to pause now. Okay, here we go. We're going to basically be making a scattergram and turning it into a line graph to do this. So this is how we do this. We're not actually going to be using our data analysis tab. We're just going to be going and doing a scattergram. Okay, so I want you to highlight this data, not the titles, nothing else, just the data. You see this little one here with just the dots? That's a scatter plot, scattergram. Just select the basic scattergram for me. And this is what you get. That's your plotted data, each one of those points plotted out. So day 4, you had 110, 185, plus quite a few other things on day 4. So they're all plotted there. So that's a basic scattergram that we have there for all those different groups. Now right now that doesn't look like it says much, but what we're going to be doing is we're going to be adding in some lines of best fit here. First of all, let's just name these little series here. So series 1, 2, and 3, let's give them a name. Now we want it to be a little bit better than 0.33. Let's put 0%, 33%, and 100% like I had before. Okay. And we'll tell it where to get those names from. So you have to tell it how to name those series there. So we go select data, and we're not looking for category labels here. There is no categories on this graph here, it's over time, but we need to tell it the name of each of these series. Okay, so series 1, which is our first one, that's my 0% nutrient, and you can even, if you change it to 0%, it will reflect that as well. For series 2, if I can even do that now, nope. Series 2, tell it where to get that from. And series 3, done. And then you go OK. And that will now reflect in there. So if I actually change that now to 0%, so I've changed them, and look at what happens here on my graph, wherever it is, changes it down there. It changes my legend. So that means whenever you do have to make changes, it will just update. You can also add the title in, which is basically looking at the growth rate or the number of thalia in different concentrations of nutrient. These numbers on the side here, we need to tell it what they are. That is our counts of thalia, so add a chart element. Vertical axis, that is our number of thalia. Okay, and we have to tell it what the horizontal axis is as well. The horizontal axis is days. Yeah. So now we've got a basic chart that shows us this. Now we just have to get some lines in here to unmuddy the waters and make it a little bit clearer as to what's happening here. And we do that by adding lines of best fit. So first of all, we're just going to click one of these guys here. I don't know if you can do it down below here. No. If you click here on just one of these colors, like the orange, it will select them out. You go to chart design. Again, add a chart element, and we say we want to add a trend line. I want you to go to more trend line options. And the first thing you're going to do is select polynomial. That allows us to set it up as a curve. Okay, now we don't want it to be, when we do growth curves, we know that it goes up and then it turns around and turns into that S curve there, which is what we call a logistic curve. To set it at that type of curve, we need to turn it to an order 3. Okay, so make sure you select polynomial order 3 so that you set it up so that it's looking for a logistic curve, which is what we know growth rates should show. The next thing I need you to do is click this R² value. That basically is a measure of how well the orange dots fit that logistical curve there. And the closer it is to 1, the better. Okay, so make sure you pop that in, and then you're going to do that for the other ones. So I'll just speed up the video here. Now at this stage, if you have these little R² values and they're a little bit hard to see, or you have to move them around, you can. So I'm just going to drag this one down to there so I can easily tell who he belongs to. You can even change a few other things with him, like the color of his text and stuff. Really important that you're able to tell which one of these R-squared values belongs to what, because each one is a different growth. Okay, so there's basically the logistical curves that I've set up for each one of my beakers. You can change a few other things here, so you can fiddle around with your label options and your text options if you want, but you can also highlight these little lines here and make them look a little bit better by making them thicker and stuff. Something here. Yeah, you can make them a lot thicker, and that just makes it a little bit easier to see them. You can even turn them from like dotted lines into solid lines and stuff, so it's a little bit easier to see them apart from those dots that you've got there. And it just makes it a little bit easier to actually read this graph. Again, you can move these little text boxes and stuff around, so it's also easy for your reader as well. The other thing you could do is make sure you put these down here so that you can actually see them. So this R-squared value here, that's for my blue one. I could actually put it just down here. Now that R-squared value was for my orange one, and my R-squared value there was for the grey-brown one. Just if they overlap and they're really a bit hard to see which line it belongs to, you can also reorganize it like that. So now you have these growth rates plotted out like this, and you can see again something that we already found out when we were doing the growth rate comparison in the bar graph, that there is statistically quite a significant difference between the distilled water and the other two groups. However, the other two groups, there's not really an awful lot of statistical difference between them at all, and I think that's to do with the amount of error that's in there. So let's see if we can then do some interpretation with this regression analysis. Essentially, you can see that there is definitely a difference in the growth rate of the different mediums. However, as we already knew before, there is a significant difference between the growth rate in the distilled water here, okay, compared to the 33% and the 100% medium. There's a significant difference between those. We already knew that from the standard error analysis. However, when it comes to how reliable this data is, we actually have to do a regression analysis to get a better picture here, especially when it comes to which one of these two here, my 33% or my 100%, which one of these is the one that is not telling the true story because of the error. That's how this can help us here. Let's have a look. Now, when you have a look at these regression lines, I'm actually going to start with the blue one down the bottom here. It has an R-squared value of 0.3357. An easy way for you to change that is to basically a percent. The closer it is to 1 or 100%, the better the reliability of the data is. Okay, so if I look at it, and I've just actually written up a little thing here to help explain it, I could actually say here that the R-squared value of the distilled water here is 0.3357, which means 33% of the growth of the thalia. So 33% of that data is actually explained by the change in time. That's what it means. So some of this, it changed, but it didn't change relative to time. Something else was affecting it. That's essentially what it's talking about. 33% of those dots can be explained by just the change in time, which basically tells us that we do have very low reliability here when it comes to our distilled water growth. Not the best reliability that I was hoping for, but hey, that's what happens, especially when you've got multiple groups taking down data. Now let's have a look at the 33% growth medium. I'll just adjust this down. So it had an R-squared value of 72% or 0.7263. So a quick interpretation of that would be that the R-squared value is 0.7263, which means 72% of the growth of Thalia in the 33% medium can be explained by time, which is actually not as bad as we thought. 72% of those dots actually fit in with that logistic curve as time goes on. Now let's have a look at the R-squared value for the 100% medium. It has an R-squared value of 0.92, so it's actually the most reliable of all of them. 92.9% of its data, so basically 93% of its data actually fits that curve and is affected by time. So that's how you could actually write up an interpretation of that data and how reliable it is using those R-squared values for that. So if you do that R-squared analysis, basically you are looking at the reliability of your data points. It doesn't always line up with standard error, okay? It's looking at how well these points fit a logistic curve, okay? And if you don't set those curves up right, then your R-squared values will actually be incorrect anyway. But it's seeing how well they fit that growth curve that we were looking for, the S-curve. And it's really easy then to use these values then to talk about whether or not your data is reliable or not, and where you have some unreliable data. So that's how you would use this regression analysis to talk about the trends, to talk about how reliable your data is using those statistics. So make sure you put those interpretations in so that you can then go and draw some conclusions.